This session is going to be about the comparison test. We learned a couple of techniques so far, but as we have seen, end-term tests can be sometimes inconclusive, and an integral test is good, but what if you cannot take the integral, right? That's why we are going to need some other tests besides all of other tests, and then we are going to learn more tests after the comparison test. So let me give you, what we mean by comparison test. To be able to use this test, I'm going to use two series. And the first condition I need to satisfy is this inequality. Look at that. One of the right series general term should be bigger than another one, and then both of them should be positive. What it says? It says if you know the convergency of the bigger one, right? The smaller one is going to be convergent. Why? Since this is going to be the number, right? And then if you have a series which is less than this number, of course it's going to be convergent. So I can say that AN is going to be convergent. If I think the other way around, let's say this time, right, the smaller one is divergent, which means, as you know, right, it's infinite. So what can I say about the bigger one? Of course, if I can find something, right, which is bigger than infinite, that's going to be divergent. That's all. That's what we call the comparison test, guys. But as you notice, right, I need to know two things. I need to satisfy two conditions. First of all, if my question is about AN, I should be able to find a BN, which I know is convergence, right? If the question is the other way around, I should find a series which is less than the one, right, I know, then I should know if it is divergent. So let's look at the examples and then try to understand how I can apply the comparison test. 1 over n to the 4 plus 5. Yeah, so I can start by 0 or 1. We will talk about later a little bit, but so let me keep for you just 1. I can use, first, I can start by end-term test again, right? Before the comparison test, end-term test. These are also, right, the extra examples for you how I can use, right, the whole other tests besides the test we are learning right now. If you want to use, right, the end-term test, look at that 1 over n to the 4 plus 5, which is 0 as you see, right? That's why it is inconclusive. If you want to use the integral test, you should take the integral of this one, which there is no technique you can take this integral at this point. Since if you had here the x squared, that would be, right, easy. But if you have the x to the 4, you cannot use it. Look at that. Both techniques, right, failed. Now, I will try to use comparison test. So my end term here, right, an is equal 1 over n to the 4 plus 5. And then I should find the bn. And then I should show, right, this bn is bigger than an. And also I need to know if it is convergent. If I can't show the convergence of bn, I can't use the comparison test. So as you see, I have a lot of problem around. But fortunately, there are a couple of easy ways, for the comparison test. How am I going to choose the bn? The easiest way is this one. Look at that, guys. To be able to choose the bn, just use, the degree of the bottom term of an and then lowered. As you see, although I don't have the n to the 0, I can just put there, right? Look at that. And I can take the n to the 0. What I have right on the bottom, 4. So I'm going to put here n to the 4. So bn could be chosen n to the 4, 1 over n to the 4. Great. Let me choose this. But the second part is, right, I need to show if AN is less than BN, right? I don't know. That's the second part of the comparison test. To do that, I will use this one. If you remember from the integral test, we did the similar things, right? N to the 4 plus 5 is bigger than N to the 4. And if I flip this inequality, I would get N to the 4 plus 5, which is less than N to the 4. Sorry. You can use the equality 1 over N to the 4. Okay, look at it. Now I satisfied right inequality. Now the third question, if 1 over N4 is convergent, still I don't know if it is convergent, right? I need to use all other tests I have learned to check if it is convergent. So how am I going to check it out? I can't use n-term test, which is inconclusive, but look at the integral test. Integral test for this one, 1 over x to the 4, from p-test, right? This is going to be, since p is equal to 4 bigger than 1, this is going to be convergent, right? That is why, look at that, if Bn is convergent, since 1 over n to the 4 is convergent, right? And 1 over n to the 4 plus 5 is convergent due to, right, comparison test. I hope you learned how I use the comparison test. Of course, we are going to solve more examples. Look at this one. N is equal 1 to the infinite, n cubed over n to the 6 plus 2n plus 7. I will use the similar techniques. What I said, this is my an. I need a bn, right? I need to choose what the bn is, and then I need to show the convergence of bn. So you saw how I chose what the bn is. I can also use the same technique I used for the previous example. Bn can be chosen in this way. Look at that. The n cube is, right, the highest degree term in an on the in the top, and n to the 6 is the highest degree term in the bottom. So I can just choose, right, Bn in this way. But I'm not gonna use this form right now, since I need to show, right, this inequality holds. How? In this way. N to the 6 plus 2n plus 7 is bigger than n to the 6. If I flip this, that would be equal this, and that's gonna be less than 1 over n to the 6. If I multiply by n cubed, that would be equal this, which is less than n cubed over n to the 6, which is equal 1 over n cubed. This is my bn, guys, and then this is my an, as you see. And then I satisfy the condition of the comparison test. Now the last condition is to check if bn is convergent. What is my bn? Bn is equal 1 to the 1 over n to the cube, n cubed. And I know from the, right, integral test and also p-test you can use, this is convergent, right? Why? P is equal to 3, bigger than 1. That's why my an, right, which was equal n cubed over n to the 6 plus 2n plus 7 is convergent. Another example. Another example would be this. 3 over n minus 2. Let's look at the convergence using the comparison test. As we did in previous example, we can start, okay, using the denominator. So denominator is less than n, right? And I can flip this And do I know if this series is convergent or divergent? Yes, I know, right? This is my harmonic series. Harmonic series. And it is divergent. Since this series is divergent, right? And using the comparison test, right? Because of comparison test, I can say that this series is also divergent, is divergent. Why? Since if the smaller one is divergent, of course the bigger one is going to be the divergent, right? I just used the second part. We forgot here to multiply by 3. Of course, you can multiply by 3 both sides, okay, to get the term. So let's show another example. N over n to the 5 plus 4. So question is same, and then I want to use the comparison test. First step is to choose what the Bn is. When I choose, right, I always use this technique. Please take the highest degree term on the top and then on the bottom. That's the right. That's gonna be the series I'm gonna be comparing my original series. How am I gonna compare? That's the usual steps I always take. So look at that. This term is bigger than n to the 5, and I'm gonna flip them. N to the 5 plus 4, which is less than n to the 5. Then I can multiply by n, right? So multiply by n. This inequality will turn into this one, n over n to the 5. You see, this is my Bn I decided to choose at the beginning. I obtained it. So it is equal also, right, this one. This is my Bn. So now, the second step, I need to investigate if this is convergent. So, if Bn, right, series, not the sequence, is convergent, yes, because of p-test. So p is equal 4, bigger than 1, right? That is why it is convergent. And I know my Bn is bigger than An. That is why my An, right, is also convergent because of comparison theorem.